6th grade, Module 6, Lesson 18, Classwork, connecting graphical representations and numerical summaries. Example 1, summary information from graphs. Here is a data set of the ages in years of 43 participants who ran in a 5K race. So here are all the ages, you can see them, and then it already gives us the minimum, median, maximum, mean, and MAD, and it's plotted it for us in a dot plot and in a histogram. So number 1 asks, based on the histogram, so this histogram, would you describe the shape of the data distribution as approximately symmetric or as skewed? Would you have reached the same conclusion looking at the dot plot? So would we say that this is symmetric or skewed right or left? I'm noticing that there's a pretty steep incline there, and this one is a little more angled down. So I think it's skewed a little bit to the right. And I'd say the same thing here. It looks like it kind of tapers out a little bit more to the right. So I would say that they're both skewed a little bit to the right, just slightly. So let's say both are slightly skewed right data distributions. If there had been 500 participants instead of just 43, would you use a dot plot or a histogram to display the data? So if there were 500 instead of 43, I would use a histogram, because a dot plot, that would mean that you would have 500 dots. So there would be lots of dots. It would take you a very, very long time to graph it. Whereas this, we could just, if there were, instead of 14 or 13 there, if there were like 25, we could just make it bigger. So it would be a lot easier to plot everything in a histogram than it was here in the dot plot. So I would use a histogram. Because dot plots don't work well for large data sets. Since you have to plot each and every data point. Number 3, what is something you can see in the dot plot that's not as easy to see in the histogram? So kind of like what we talked about in number 2. The dot plot, it's easier to see every single data point. So we can see the exact minimum. We know the minimum is right here, about maybe 18. We can see the maximum right there, probably 61 or 62. Here, we don't know what the exact minimum is or how many there are. It would be hard to find the median because it's just somewhere in the middle. We don't know exactly how many are there of each in between. So let's say, what's something you can see in a dot plot? We can see all of the actual data plots or data values. We can see that the minimum is 18. And we could find the median. So we could find the median by crossing it off and finding the middle. It tells us what the median is, 35, so we don't have to find it. So we know that for each one. But we could have found that using the dot plot. It would have been a lot more difficult to find, or maybe impossible to find it using the histogram since we don't have all the actual data points and know how many were at 30, how many were at 31, how many were at 32. We just know how many were in between, for example, 30 and 35. Or we know that how many were between 30 and 40, but we don't know exact numbers of how many were at each exact number or each exact plot. So we could also see that the oldest runner here, who is 74, and so we don't know that they're 74. We just know that there is one of them and that they're in between 70 and 75, but we don't know how old that person is. So we can see the minimum and the maximum. We can see, so the oldest runner is 74, but on the histogram, we would only be able to see that they are between 70 and 74. So that's just one example of how it's easier to see. Okay, number 4, do the dot plot and histogram seem to be centered in about the same place? Well, I would say yes, they should be because they have the same data. It's the same data, so they should be centered in the same place. Like, maybe around here, 34, is it? So we can see that they are like kind of centered around there and the same on each one because they are, at the end of the day, they're the same graphical information. It's plotting the same stuff. So yes, both graphs are based on the same data. So they should communicate the same info. Just rewrite that. Same info about the center. Number 5, do both the dot plot and the histogram convey information about the variability in the age distribution? So kind of the same thing. They should communicate the same information. So back to what we said about number 4. However, like what we said here in number 3, where we can tell the exact minimum and the exact maximum on the dot plot. Here, minimum. Here's the maximum. So we know 18 and 74. But here we just know it's between certain ages. So we just know it's between 15 and 20. And here it's between 70 and 74. I guess this would be 15 and 19. So we don't know the exact age. We just know general. But it is conveying the same information. So yes, both are based on the same data. However, the oldest runner appears to be a more extreme departure from the rest of the data in the dot plot. This doesn't show up as well in the histogram. Let's look at that. Here you can see there's a lot of difference between these points. It looks like a big gap there. And here it's just like, just a little bit. So you can tell that there's a big difference from how this is further away from the rest of the data, whereas here it looks more extreme in the dot plot. Number 6, if you did not have the original data set and only had the dot plot in the histogram, would you be able to find the value of the median age from the dot plot? So yes, you would be able to find the value of the median age from the dot plot because you still have every single data point. So we could count off and find the middle of all those data points because we have every single data point. We would not necessarily be able to do that with the histogram. So yes, we have all the data points on the dot plot. Explain how you would only be able to estimate the value of the median if you had a histogram of the data. So you would only be able to estimate because we don't know the exact values of the data points on the histogram. So for example, let me clear some of this off. If we were looking between ages, let's say 30 to 34, so here ages 30 to 34, we know that there are, that would be 13 people between ages 32 through 34, but we don't know how many people are 30, how many are 31, how many are 32, how many 33, 34. We just know there are 13 total. Whereas here we can tell between ages 13 or 30 and 34, there are 1, 2, 3, 4, 5 people who are 30. One person's 31. 3 people are 33. No one is 34. Does that make sense? I hope so. Okay, so let's say, for example, between 30 to 34, there are 13 people, but we don't know how many are each exact age. So like 31, 32, 33, etc. Number 8, suppose that a newspaper article was written about the race. The article included the histogram shown here and also said the race attracted many older runners this year. The median age was 45. Based on the histogram, how can you tell that this is an incorrect statement? So they're saying that the median age was 45, which would be about right here. So I would say that's an incorrect statement because if you're looking at the data, a lot more of the data is to the left, is over here. So the median means it's the number that was in the very middle, the data point in the very middle of all the other data points. So it looks like there's a lot more data to the left. So I would think the median would be more about there. So let's just say from the histogram, it appears that less than half of the runners are 45 or older. So I think the value of the median appears to be in the 35 to 40 age range or age interval. So I think it's somewhere like in this one. right here, between 35 and 40, not all the way up there at 45. Number 9, one of the histograms below is another correctly drawn histogram for runners' ages. Select the correct histogram and explain how you determined which graph is correct and which is incorrect based on the summary measures and dot plot. So this we're going to have to go back up to the dot plot and all of the ages, the exact ages, and figure out which histogram is correct. So I noticed that the age ranges, how these two differ. This one starts from 12 to 24, 24 to 36, whereas this one starts 10 to 22, 22 to 34. So I'm going to go back up to the dot plot, the age ranges, and I'm looking at the age ranges, and I also have the histograms on another screen, so I can compare them. From looking at the dot plot, I can see that if we compare it to the first histogram from ages 12 to 24, looks like there's only one person that they think that they have graphed there from ages 12 to 24. But on the histogram here, I'll use pink. We have 1, 2, 3, 4 between the ages of 12 and 24. So there should be 4 there. And then looking at the next distribution, or even that's enough for me to tell that on the second, so here we can see that there are 4 people between ages 12 and 24. But if we go down and look at these histograms here, in the 12 to 24 age range, that's probably 1 or 2. So that's one person. So automatically I know that this is not correct. And then here between 12 and 22, it looks like there are 3, which would be correct because I think one of those 4 people up here was older than 22. So I would cross that one out. So there's those 3. So based off of the first interval, I already know that the first one has to be correct. So we can kind of explain that to show that, say, the histogram on the right is correct. Because it shows 3 people in the 10 to 22 range, or should we call it group. The left histogram incorrectly shows one person. So it only shows one person in the 12 to 24 group when there should be, when the data has 4 people. So if you go on, you might find more mistakes or fewer mistakes, but that one alone shows me that it has to be the one on the right. Number 10, the histogram below represents the age distribution of the population of Kenya in 2010. A, how do we know from the graph above that the first quartile, Q1 of this age distribution, is between 5 and 10 years of age? Okay, so we know that the first quartile, Q1, is equal to the lowest 25%. So the bottom 25% is quartile 1. The middle quartile was 25 to 50%. The third quartile is 50 to 75, and the last one is the top 25%. So how do we know that the first quartile is between 5 and 10 years of age? So here's 5 and 10. So this is the percent. So looking at the graph, we know that 17% is in the first age range. So we're already at 17%. And then the next age range is 5 to 10, and that appears to be like 15%. So if we already have 17% plus the 15%, then we've already reached 32%. right? So the first two age distributions are greater than the 25th percentile. So these two have already reached further than the 25th percentile. So that means that in between 5 and 10 lies the 25th percentile. I'm hoping that's making sense. So how do we know from the graph distribution that it's between 5 and 20? So we're looking for, let's try and describe this. So we're looking for data value such that 25% of the distribution is at or below that value. So 0 to 5 age range is equal to 17%. So the lowest 17%. Let's make that a little more clear. Is the lowest 17%. Based on the data, I found that from the chart here. So it was that 17% is between age 0 to 5. And the next group, 5 to 10, and the 5 to 10 group is about 15% of the distribution. Right, so the next group is about 15% of the distribution. So that means that 17% is below 5, and then the 17 and 15% together, 32%, is below the age of 10. So 25% mark would be somewhere in between 5 and 10 years old. Okay. I feel like we explained that pretty well. Okay. B. Someone believes that the median age in Kenya is about 30. Based on the histogram, is 30 years a good estimate of the median age for Kenya? Explain why or why not. Okay, so they're saying that someone says that the median age is 30, so right here. So just by looking at it, I can see that 30 might be about the halfway point, but these values are very small. So adding them all up, you're not going to get a very high number. These values are very large. So like we said, before we even got here, we were already at 32%, and we're just looking for the top, where the 50% mark is. So I'm going to say not a good estimate. We're looking for the 50th percentile, which we could find by, so we're already at 32%. Here, this is 11, so that's 11%. So now we're at 32, 43%. And then this is another 10, so that's 53%. So I would think that the median age is in between there, in between 15 and 20 years of age. Or I wouldn't think, it is. It's a fact. We can see it right there. So it should be between 15 and 20 years of age, because that's when we reached between the 50th percentile. It lies somewhere in there. We just don't know exactly where, because we don't have exact data points. So let's say that no, the median is not 30. The 50th percentile lies within the 15 to 20 age group. All right, number 11, the histogram below represents the age distribution of the population of the United States in 2010. Based on the histogram, which of the following ranges do you think includes the median age for the United States? 20 to 30, 30 to 40, or 40 to 50? So just by looking at it, I'm going to go with the median is maybe somewhere in here. So I would say between 30 and 40. So I didn't even look. I just looked at the graph and thought where about the 50th percentile would be, and then it happened to be, I picked 35, so that's between the 30th and 40th percentile. So, and you could have added it up too. So if you want to be more specific, which you should be, you can look at the percentiles. So there's like 6.5%, 6.5%, 6%, 7%, and add all those percents together until you get to about 50th percentile, and you'll find the median. So the median appears to be in the 30 to 40 age group. Because, so why? Well, we could add up all the percentages. So that's about like 6.5 plus this one. Let's do another 6.5 plus, let's just call that 7, 7, 7, 7. So 3 sevens plus another 6.5. So let's see where that's gotten us. So these 3 sevens would be 21. This is going to be 13. And then 7 plus 6.5 will be another 13.5. So 13 and 21 is 34 plus 13.5 would give us, let's see, 47.5. So specifically, if we want to, so right there, we haven't quite reached the 50th percentile. So if we add another one, we'll get, so that's about another 6. We'll get 53.5. So that's saying that in between these two, so specifically, it would be in the 35 to 40 range. Because this is about 47 percentile and this is about the 53rd percentile. So the 50th percentile is going to be right in the middle there, somewhere in here. We can't figure out exactly what it is. So because of what we just did the math there. Okay. Number 12, consider the following 3 dot plots. The same scale is used in each dot plot. Okay, so 3 different plots. We have the same scale, 2, 4, 6, so we're counting by 2s. Okay, which dot plot has a median of 8? Explain why you selected this dot plot over the other 2. So a median of 8 right here. So we're looking for which one. The middle is about 8. So I'm not going to pick plot 1 because the median looks to be more in this range. I'm not going to pick plot 2 because the median is more right here. So it has to be plot 3 because that's kind of where the middle of the data lies. So plot 3 is the only distribution. Centered near 8. B, which plot has a mean of 9.6, 9 and 6/10? So this is an average. So here we're going to change to green. So 9 and 6/10 would be about here. So let's see, if we're looking at it, I'm not going to pick the plot 2, obviously, because that's past where any of the data points even are. Plot 3, it's towards the end. So the average, it wouldn't make sense that the average would be all the way at the end by the few larger numbers. And here, This seems to be kind of in the middle, and typically the average is related to the middle. So I'm going to go with plot 1. So plot 1, it's the only dot plot that the mean could be as high as 9 6/10. And C, which dot plot has a median of 6 and a range of 5? Explain why you selected this. So median of 6 and range of 5. Let's go purple. Okay, median of 6, so that means right there, right there, right there. I'm already going to cross off plot 1 because it doesn't make sense that the median would be at the very beginning. And a range of 5. So this one ranges from here, that looks about 3 to 8. So that would be a range of 5. This one ranges from 2 to 10. So that's a range of 8. So it has to be plot 2 because it's the only one that has a range of 5. Let's say plot 2 only. So it's the only one centered at 6 and only plot with a range of 2 or a range of 5. And that's the end.